Hello everybody. So I'm going to be working on example 1 and the monitoring progress questions for day 16 of our notes. So example 1 says placing a figure in a coordinate plane. So like you saw in the notes, we are able to get figures or any polygon and put it in a coordinate plane just like we did in the explorations. So we have to place each figure in a coordinate plane in a way that is convenient for finding the side lengths. Assign coordinates to each vertex. And so at first this might seem a little bit weird because we have full control of what variables and what coordinates we can use without actually giving them a number. So for A, one of the easiest ways that we could put a rectangle in a coordinate plane will look like this. If I have a coordinate axis, and let's say I put one point of the rectangle there and another one right here. So this is my origin, so my origin is always going to be 0, 0. And let's say that I went over here at a height h. So if I want this to be h, this side here to be h, this coordinate has to be the coordinate 0 and h. So that's one of the side lengths for the rectangle. Now if I put the other vertex of the rectangle over here, and I want to call this my length, then I'm gonna put an L right here, and so this tells me that this point has to be the point L0. And lastly, we have 1, 2, 3 points. We need the fourth point for the rectangle, which should be right here. And so if we connect my rectangle, and if we want to figure out what coordinate are we going to put here, well, we just said that my x coordinate is L, so this has to be L. And we just said that my other side is H, so this right here also has to be H. And so this right here is one possible answer of how we can put a rectangle in a coordinate in a way that is convenient to us so that we can find the side length. Remember, it's always easier to work with lines that are straight, right? That are either horizontal or vertical, because those are the easier ones to find the length for. So that's the one for rectangle. Now let's do a scalene triangle. So if we remember, scalene triangle means that we're not going to have no equal sides. So all sides are different. All of these sides are different. And so this tells me that, once again, I'm going to do a coordinate plane like this. And because I want all of my sides to have a different length, I'm just going to go ahead and mark my first point right here. And then I'm going to make some line over here, and then another long line over here. So we know that none of them measure the same length. And so now all we have to do is use different variables, right? Remember, because they don't have equal sides, we cannot use the same variable. And so this one just becomes, we can do it any variable. I'm just going to use D. So x is D and y is 0. Notice how we are in the x-axis, so we are not moving up or down. That's why my y is 0. And then this third point over here has to be, again, other different numbers. So I'm just going to use f and g as my new variables. And so now these 3 points are the possible points that we can use for a scalene triangle in the coordinate plane. Now, the monitoring progress example is very similar. In fact, number 1, we have to use the exact same rectangle, right? They're telling us, show another way to place the rectangle in example 1 and assign you coordinates. So like I said previously, this is just one example of how I can put the rectangle in my coordinate plane. We can very much put it another way and it will still work, right? Another convenient way that we can use is the following. So if we do my axis again, And now let's say I want to do my length first. So I do the long side first, and so I'm going to call these my L. That tells me that the origin is 0, 0, and that this point up here has to be 0 and L. And then if I want the width right here, or H, to be the small side now on down here, then we can call this second point H and 0. And then all we need now is this fourth point there. So we're going to connect all of my points. And we're going to notice that if I want to find this point here, I have to go H to the right. And then I have to go L up. And so if you notice, these are not the same these are not placed the same way, but they are exactly right? So this is another way that we can place a rectangle in my coordinate plane, and it will still work. And here are my new coordinates. And then number 2 says a square has vertices 0, 0, M0, and 0, M. So let's see, I'm going to draw these. So there's my coordinate. We have vertices 0, 0. We have another vertex over here, M0. And then we have a third vertex is 0, M, right there. And so if we connect these, and to make a square, the only one that we're missing is this one right here, the top right corner. And again, because we know that my x value from here to here is M, because I know that my y value from here to here is M, this coordinate here has to be x is equal to M, and then y is also equal to M. Because this is a square, every single side has to be congruent.